Hi, my name is Siti Nurdina Alena Binti Hassan. My battery number is F509200001. I'm a student of Foundation in Science, BComs International College. This video is an assignment for Chemistry 2, CFS 1234. The title of this experiment is The Reaction of Aliphatic and Aromatic Hydrocarbons. Hydrocarbons are organic compounds that contain only carbon and hydrogen. For instance, alkane, alkene, and arene. Alkane is saturated hydrocarbon that do not contain double or triple bonds, so it does not have any functional groups. Cyclohexane is an alkane that will be used in this experiment. Alkene is unsaturated hydrocarbon that contains at least one double bond between two carbon atoms. The functional group of alkene is carbon-carbon double bond. Cyclohexane is an alkene that will be used in this experiment. Lastly, arene is an saturated aromatic hydrocarbon with stable molecular structure. Functional group of arene are benzene ring. Toluene is an arene that will be used in this experiment. Next, there are two objectives of this experiment. The first one is to study the chemical properties of an alkane, alkene, and arene. Second, to differentiate an alkane from an alkene and arene. The apparatus that we need in this experiment are dropper, test tube, rubber band, labeling paper, test tube rag, and black sugar paper. Chemical reagents that will be used in this experiment are toluene, cyclohexane, cyclohexene, dichloromethane, 0.01 molar potassium permanganate KMnO4, and 4% bromine in dichloromethane. There are two parts in this experiment, which are Part A and Part B. In Part A, we are going to observe the hydrocarbon reaction with bromine in dichloromethane, while in Part B, we are going to observe the oxidation of hydrocarbons with cold alkaline solution of KMnO4, which called Bayer test. As we can see, there are two figures, each for Part A and Part B. So here is the method that we use to investigate the chemical properties of alkane, alkene, and arene. Here are the results of this experiment. From the result, when cyclohexane, and toluene will react with bromine in the dark, it will decolorize the reddish brown color of bromine. But if the reaction occurs under the sunlight, only cyclohexane will decolorize the reddish brown color of bromine, while others remain unchanged. Besides that, when cyclohexane, and toluene undergoes the Bayer's test, only cyclohexane decolorize the purple color of KMnO4 and brown precipitates will form, while others remain unchanged.
Discussion Part A. Cyclohexane undergoes free radical substitution reaction in the presence of sunlight. So, draw cyclohexane react with bromine in the presence of CH2Cl2 in UV. The product form is cyclohexane attached to Br, and the side product is HBr. 2 Roman. Cyclohexane undergoes electrophilic addition reaction with or without sunlight. So, draw cyclohexane react with bromine in the presence of CH2Cl2 in UV. So 2Br will be added to carbon-carbon double bond. The second one, draw cyclohexane react with bromine in the presence of CH2Cl2 in the dark. so 2Br will be added to carbon-carbon double bond. 3 Roman, toluene undergoes free radical substitution reaction in the presence of sunlight. So, for the equation, draw structure of toluene, benzene ring bonded to CH3 plus reagent Br2 in CH2Cl2 in the UV, and the product form is benzene ring and CH2Br and HBr as the side product. Next, part B. 1 Roman. Cyclohexane cannot be oxidized. So, draw cyclohexane, react with reagent of Bayer's test, which is KMnO4 and OH- cold, and the reaction has no observable change. 2 Roman. Cyclohexane is oxidized to form a diol or glycol. So, draw cyclohexane plus KMnO4 and OH- cold. The reaction occurs, so 2OH added to the carbon-carbon double bond and also form MnO2 that gives brown precipitates. 3 Roman. Toluene cannot be oxidized. So, the equation is toluene bonded with CH3 plus reagent Bayer's test, which is KMnO4 and OH- cold, and the reaction has no observable change.
In conclusion, the objectives of this experiment are to study the chemical properties of an alkane, alkene, and arene can be achieved. From the experiment, we know that cyclohexane and toluene undergo the free radical substitution with bromine in the presence of sunlight, while cyclohexane undergo electrophilic addition with bromine with and without sunlight. Besides, cyclohexane and toluene cannot be oxidized with Bayer's test, while cyclohexane can be oxidized with Bayer's test.